Okay, so with geometric sequences, sometimes they ask you to figure out, again, the sequence doesn't have to be infinite, so in this case, this one starts at 65,536 and ends at 16, and they want to know how many terms, basically total is the whole thing. So you can think about breaking this out. First, second, third, we don't know how many, and then what term number is 16. So knowing that our Tn values are down here, and our n values are up there. So that's what we're looking for. What is n when our actual value is 16? So like many of these things, the first thing we're going to do is try to find the common ratio between the terms. And these are awfully big numbers, but I'm double checking. Do they add by the same amount each time? Because I know it's a geometric, I should think, well, it's not going to be an arithmetic sequence, so they're probably not going to add by the same amount. Here they're going to times or divide by the same amount. And if you notice, these numbers are actually getting smaller each time. So I should expect my r value to be less than 1. And again, if you can't remember how to figure out the r right away just by looking at it, you can find your r value by picking a term, a value, 32,768, and dividing it by the one in front of it, 65,536. So if we divide term 2 by term 1, we get 0.5, or a half. And you can do it again to double check if you want. We can take term 3, 16,384, and divide it by 32,768, and again we'll get a half. So I know that r is equal to a half, or 0.5. You can leave it as a decimal or a fraction. The first term, that's easy, it's given to you there, so we know that r is equal to 0.5, a is equal to 65,536. And then the last thing that we need to look at here is the last term that's been given in this series. So it ends at 16, so that means that my t sub n for the formula I'm going to fill in is 16. So I don't know what n is there, but when I have a value of 16, what is n? So I'm going to plug in a, r, and t sub n into the formula, and I'm going to use solver to solve for n. So my formula is Tn is equal to a, r, into the negative 1. So I'm going to plug in what I know. 16 is equal to a, which is 65,536, times 0.5, which is r, to the power of n minus 1 using brackets. So again, you'll use your little arrow, upside down caret power button, and make sure you get the brackets. So if we put this into solver, so you can use solver, we should be able to get a value for ourselves here. And in this case, we should get n is equal to 13. So we have 13 total terms. Again, if you feel like you've had enough, feel free to stop the video, go on and do some of the practice. If you want one more example, I will go through one more. So looking at this one, find the number of terms in the following geometric sequence. Again, trying to figure out what is the value of n out here over the top of 8,192. So when my term value is equal to 8,192, what term number am I actually at? So I'm going to find r first. And I actually notice here r is going to be timesing by 2 each time, but if you're not sure, 4 divided by 2, taking term 2 divided by term 1, gives me 2. A is equal to 2. And t sub n, the last term they've given me, is equal to 8192. So plugging that all into my formula, using this one here, t sub n is equal to 8192 is equal to a, which is 2, times, don't forget the invisible times sign there, r, which is 2, to the power of n minus 1, which I don't know. And again, in your calculator, you might have that written out like this, 2 times 2, using the power button there, like the little upside down arrow. So we can put that into solver, and we should get our value of n from there. And by luck, n here is also equal to 13. Don't worry, every answer will not be n is equal to 13. So give a go with that. Make sure you're careful about solving for your r and careful about putting it into the calculator, and you should be okay.